Hey, it's Henry here. I'm going to be demonstrating streaming data from a XULA FPGA dev board to the FT2232H FTDI USB FIFO chip. This chip has been put into FT45 or FT245 mode, so it's a synchronous parallel 8-bit transfer out. So let's go ahead and start the demo. First off, we need to push our binary program up to the XULA FPGA, our hardware design. I've already synthesized this on a Linux box, so to program it, we're going to be in the demo directory. This is in the Platypus FPGA demo directory. So first comes first, we need to type make, type an F make file. The nice thing is you can just type program XULA. This will actually do the hard work of programming the XULA. Now you can't see this on your side of the screen, but I watched the green LED blink on the XULA to tell me that it was successfully programmed. You could ignore these arrows. The reason they're appearing is because we're on a Mac and it can't synthesize the binary. That's okay because the binary has already been synthesized and I don't need it right now. Here we are back in the Platypus directory. Let's go ahead and list the directory so you can see what it looks like. First thing we're going to make a FIFO. This is a named pipe. We're just going to call it data. If we list the directory, we see the data. Okay. To test it, we need some type of executable to interface with the FT2232H chip. We're going to use the library FTDI. Fortunately, they've included some really nice example code that is going to work for our application here. So if we look in the, if you follow the instructions to how to build the entire project, you'll find that it's in a library, build, or library FTDI, build examples, and you'll see the one we're interested in here is a stream test. So we're going to go ahead and run stream test, and just as a demonstration, I'm going to say we're going to run it without going to FIFO. We're going to go into something called the dump. It's just an empty file, and it's going to ignore the formatting of the data coming through because right now the data is just a counter. So if I hit enter, we'll notice that the data rate is very high. We're talking about nearly 41 megabytes per second. This is a very high data rate. So that's pretty nifty because that's what we're really interested in this project. I'm going to go ahead and end that. Instead of going to the dump, now I'm going to actually put into the data FIFO. You'll see it actually going to a holding path here. It's waiting for something to go ahead and read the FIFO. Fortunately, I have a program that will do just this. If you run Python examples read counter and you tell it to read from the data, it will actually print the data that's coming from the XULA FPGA to the screen. And here we go. And as you can see, the numbers are incrementing. Going back to stream test, we can see that the our rate has actually dropped here. Instead of the high data rate we're getting before, we have a much lower data rate. That's purely because the Python program is printing to the screen and can't process the data fast enough that's coming from the FTDI chip. Hopefully you've enjoyed the demo. Look forward to finishing this project and developing the Platypus DAQ.